Hey guys, Tim here, Big Dog Forge. Welcome back to the shop. Good to have you here. So this week we're going to do something a little bit special. We were sent some motorcycle chain by Robert in Cork, Ireland, and he wanted to know if we could do a little video on turning motorcycle chain into Damascus. And I told him that I'd done this maybe once, twice before, and that I would give it a shot. He said there was a guy from the Ukraine on YouTube who did this sort of thing, and it came out pretty cool. So I decided I'd take a look at his video, see what that was all about, and lo and behold, he did almost the same thing that my old mentor Fred used to do. Fred did a lot of chain stuff all the time, and I remember watching him, but I never really got into it with him too much. So kind of recreated what Fred did. I'll give you some insights as to how he did it, and kind of replicated a little bit of what the guy on YouTube did. So combination of both, and I'll just kind of walk you through how I do it. It's not so much a how-to video, it's a how I do video. So if it helps you out, great. So let's jump right into it, guys, and we'll talk to you after it. Thanks. Bye. Alright guys, we're going to jump right in. Here's our motorcycle chain from Robert, all the way from Ireland. Very cool. And we're going to take a close look at it. And there's some things about motorcycle chain that will cause you to have serious problems in trying to forge weld it. So it's made of many pieces. There's inner links, outer links, there's rollers on the inside, and they're all made of basically different materials. And some of those can be alloys. So what we're going to do is we're going to grind a link off the end here, and we'll separate it with a chisel. And what we're looking for is, a lot of chain has, under the rollers, it'll have bushings, inserts. They can be everything from plastic to bronze. There's a lot of oil in there. And a lot of times you'll get rubber or neoprene O-rings to retain the grease. So we're looking for any evidence of that, as they will cause you some issues. The chain will feel fairly tight until those start burning out, and it'll get loose and floppy on you and cause all sorts of problems. So we didn't find anything, so we got brake part cleaner here. Brake cleaner is different than carb cleaner in that it doesn't leave any residue. We're going to make a heck of a mess here, but the bench needs to be degreased anyway, so we're just going to wipe it up after the fact. Get that electrical cord off there before we blow up. Anyway, so we're going to use this brake clean, and it'll get a lot of the grease and oil and that kind of thing off to start with. And you can see a bunch of rust coming off there. It's cleaning a bunch of that off. We got some bad links in the middle. We'll have to separate those from the rest of this billet, because the bad links will give us less material in that area. I'm going to tap it on the bench and get that fluid to flow through it. As I'm wiping this up, the reason I'm showing you this, you can see how quickly that stuff evaporates, and it pretty much all goes away. So here's our little link we cut off. We're going to do a little spark test, and we pretty much know that this is a high carbon steel, and I believe those rollers are probably some sort of alloy, probably with some chromium or something in them. Okay, we're going to set our chain aside for a moment. You can notice we have rubbing alcohol. Okay, and we're going to put it in this clear container so you can kind of see what's going on. And we're going to fill this thing pretty much all the way up. We've got just a little under a gallon here. And what we're going to do is we're going to do a pre-flux. Now this is something Fred used to do. And I noticed in the video on YouTube that I saw, the guy used something. I think it was a little different. I think he used a different medium than alcohol, because it didn't quite act the same, but this works really well. Now alcohol is very thin. It's not like water or oil. It seeps into cracks and does all sorts of cool stuff. And what we're going to do is we're going to make ourselves a flux fluid out of it so we can pre-flux this chain. So we put about 3/4 cup of borax in there, and we're going to mix it up with our bestest chisel, because it's long and it reaches to the bottom. And it's going to take a while for this to completely dissolve in here, so we'll come back and mix it up a couple of times. We're going to get it started now for later. And what we'll do is we'll find an old paint can, clean it out. We'll dump that in there. We'll use our last bottle to rinse this out with. And that paint can will hold this, and the lid will seal fairly tight so it won't evaporate. We can keep it for a while. Now this is a Fred recipe, and I'm sure other folks have used it and it's been other places, but I haven't seen it, so we're going to show you how I use it. So anyway, we're marking out our chain here, and I was having a little trouble with this because we got a bad section right in the middle. So I started with 6-inch chunks because it's 4 foot long, but that kind of moved us a little bit. So we ended up with a piece in the end. So we're going to start in the middle and mark our way out at 7-inch increments, which puts us right between outer lengths. So we can cut them in half. And then that'll give us like 4 short pieces that we'll put on the outside, and we'll have to patch those together and put a little tack weld on them. Now the thing about this is when we cut this up, we're going to not put any welds in the center of the chain. We're only going to weld them on the ends. And that's to eliminate weld inclusions in the billet. And I'll show you how we're going to do that. And we need a little backer for this thing. That chain will get caught in that abrasive blade, go everywhere. There we go. Get these guys cut off. Got a couple of short pieces there. And these are going to be the main body. The other pieces we'll have to patch in. I'll show you how we're going to do that here in a minute. Get all this cut up. There we go. Check to make sure we're cutting it in the right place. Okie doke. There's our other short length. Okay, so we're going to stack these guys. I'm hitting them with a little hammer because some of them are kind of rusted together a little bit. And you notice how I'm overlapping the links so they nestle together. And then I'm setting them on top of one another. So the inner link sits on the outer link. What this does is it brings all of the steel closer together so the billet is tighter. Now this was a Fred thing as well. And notice that the guy on YouTube did that as well. And you can see our top and bottom lengths are pieced together. Those were our short pieces. So we took the lengths that we had left over, and we're going to clamp these together. And the only welds that we'll put anywhere in the middle of the billet is to temporarily hold those short sections in place so they're not flopping around. We're going to tap everything down, make sure the links are all real good and tight together on both sides. You want everything as close as possible. That way you have less dead space in between the material to fill and make it go a whole lot easier for you. Alright, we're going to grab the little MIG welder. I'm done with a stick welder for a while. And we're going to tack, like I said, all the links together at the ends. And then that's our little patch points. The other end, we'll flip this guy over and do the other side. There we go, looking pretty good. Now the next thing we're going to do is, this is something I saw Fred do on a couple of occasions. Didn't really know why or what was going on, but after watching the guy from the Ukraine in his video, the You can see how that's all put together. The sections are staggered, so they fit together. Still a little floppy, and they're offset so those links nuzzle together. So what we're going to do is grab a piece of leaf spring, and we're going to forge this down into a 1/2-inch square bar. Now, in between the inner links on that chain is just slightly less than a 1/2 inch, but we've got a piece of 1/2 inch material we'll use for a kiss block to get it close. And Floyd does a pretty good job of getting it there pretty quickly, like a couple of heats. And our billet is just about 7 inches long, so we need about 7.5 inches here. So and we're just kind of eyeballing it to get where we need to go. Maybe a little extra. And a piece of 1/2 inch round, just took that right down. Okay, and we'll finish them off with the power hammer. Scrappy doesn't feel lonely. Make sure it's nice and square. And what we're going to do with this is let it cool a little bit, and we'll mark it off. Looks like we got pretty close. And that's going to be welded along one edge between the links up against the rollers. And what that'll be is it'll be our constant, and it'll keep the chain from flopping around too much when it starts getting loose in the forge. It'll also be a nice, consistent, clean cutting edge for a blade. It'll be forged right into the edge of the chain Damascus. So we got her cleaned up, but we need to narrow it just a little bit to get it to fit between those links. I'll take it down a little bit of a V shape so we can tap it in with a hammer. And we just tack it on either end after we clamp this thing in here. Get good and tight. And that's our spring steel. So when we go to heat treat this thing, the rest of the steel in this is depending on the chain, where it came from, who made it, you know, there's a lot of variables there, but the rest of it is most likely a lot higher carbon steel. So when we heat treat this thing, we'll treat it as if it's just all spring steel. And that seems to work. All right, I get a handle put on this thing. And we've got just those links on the end to weld to. So we're going to do some good welds and get down into those links as best we can and all around them, do a little filling in. We don't want that handle coming off or separating at any point. We've got a lot of work to do with this thing. And we're going to do most of it by hand. Alrighty. Okay. So we're going to take a look at this thing real quick. Alright, you can see it there. There's our little points. So you're going to notice how they're offset, and the links are nestled together. They're offset left to right and front to back there. And that's to get all that metal as close as possible to each other, so we have fewer voids and less space to try to fill in with all that metal. You got a lot of metal to move into a space there. A lot of compression to do. So we're going to get this in, and we know there's still some oil and grease on the inside there, so we're going to let it heat up, and we'll pull it in and out, and we're going to get it to the point where the end is, a little red. Before it starts scaling too bad. And we're going to try to burn most of that grease into just carbon and flakes. That way the flux can float it out a little easier and not try to mix with it. There we go, that's probably enough. Stop smoking anyway. We're going to let it cool down to about a couple of 100 degrees, and we're going to get it into this alcohol bath. Now that alcohol has got all that borax in it. The alcohol is thin enough to get between all the links behind the rollers, and it'll carry that borax with it. So the alcohol, it's a little demonstration here of how that stuff burns. So if you get it too close to a flame, it'll start burning. It burns hot and burns fast. So you got to be really careful with this. And if you put it in the forge while it's just totally wet, you got to stand back. It'll flare up on you. The thing to do would be to just let it air dry, and you'll get a nice little white powder. You can see that white powder that's forming all over that. And that alcohol's carried that down between the links, like I said, behind the rollers. It's all through there now. It's going to give you a lot better chance of getting this chain forged well together. Alright, we'll get it up to temperature. We get some borax on the outside. We'll flux it up good. Get it back in there. Alright, you're going to notice this first welding heat I'm at regular speed, and I'm tapping it ever so lightly, just sticking things together. And we've got it pretty hot here, and if we hit it too hard, what we're going to do is just shatter that steel. It's just going to crumble. It's a pretty high carbon steel, and it's expanded quite a bit, and it'll just fly apart. So we tack it together. We're going to brush off as much crud that's come out of it as possible. A lot of that's the rust and crud and stuff that the flux on the inside started floating out. And we'll get our flux back up here. I'm going to do both sides. We'll flux her up real good. Back into the forge. And you're going to notice here that I'm cleaning off my anvil, and I left this in because if you leave too much debris on your anvil while you're doing this, you're going to create more inclusions in that chain, and it's got plenty of open space to pick up any kind of debris that's on your anvil. So after you forge each time, clean your anvil off. Get rid of all that old crust and garbage on there. Otherwise, you take a chance of picking it up, shoving it between a couple of the links in the side or the end. Now you're going to notice that link on the outside is turning darker quicker, as if it's not welded together. But you have to remember it's on the furthest outside, and those are just little fins of metal still hanging out in space there. And they need to be compressed down into the metal. So if you see dark spots here and there around the outside, don't worry too much about it. They will eventually work themselves down in. We clean the anvil again. I'm still hitting it pretty light here. You want to take your time, go slowly, little taps, start compressing it, and keep it close to welding temperature. You want it up at welding temperature through this whole process, but you want it close to welding temperature even after it's compressed. If you have any voids in there that you're trying to squish out through the entire process, you want it hot enough to weld together. So someone asked me to talk about flux a little bit. I'm going to do that while we're hammering all this out. We get this compressed far enough, we'll get it over to the power hammer to finish it off. So borax has boric acid in it. Now, people use just regular beach sand for a long time as a flux, and it works really well if your parts are clean. But it doesn't have boric acid in it, which is actually what helps lift the scale off the surface of the metal. So both of them will do a great job, but borax does a lot better, and the boric acid is the reason that it eats up the inside of your forge so badly. But it's also what helps clean the metal and float things away. So when you mix that with the alcohol, it becomes a little more liquid, and that boric acid can get inside, clean that off, and act like a flux, like it's supposed to. So that's why the solvent of some sort. Now, in watching the gentleman from the Ukraine and doing his, I don't believe he was using alcohol. with his borax, but he was soaking it, so I have to believe he was using something. I know that people have used solvents and different types of things, but most of those have oils in them, which translates into carbon under fire, which is actually more harmful than good. But I'm not sure what exactly he was using, but it didn't flame up too much when he put it in his forge, so it was a less flammable product. But we're doing what Fred used to do, so all of this is what I've been told and what I've been taught over the years. So if one of you really smart sciencey guys out there knows any more or something different, let me know. But it seems to all hold true, so unless I hear different, I'll just go with what I know. Okay, we've compressed this thing far enough we can get her under the power hammer. Finish her off this way, because we can. And we've got a little separation on that very top link where we patch welded those two together. But if we keep this thing at welding heat, that should go ahead and seal itself up. We'll find out when we grind this thing down a little later. See what it looks like. There we go. So we'll take a couple of heats on this, and we'll let it cool off a little bit and take a look at it and see what she looks like. So I was asked a question about flux and borax. There you go. You can see those little serrations down at the bottom. The links are still a little above that half-inch thing, but that's okay. We're not done thinning this out yet. We're going to get it into Floyd. We're going to take this thing down to about 3/8 of an inch. That'll give us some to grind off either end and end up with, or either side, and end up with about a 1/4 inch thick billet when we're all done. And the question about the flux was, can it be used, borax, can it be used in gas forge and a coal forge and all that stuff? And the answer is yes. Borax can be used in just about any forge that you can think of. It's even used in kilns when folks are firing pottery as a flux for metallic finishes. So yeah, it's good for all that stuff. Okay, we get this thing straightened out. Floyd did a pretty good job of getting that thing down to a skinny shape. We'll get it back into the power hammer to get rid of any of the ripples that were left in it by the fullering dies. We'll do this at a little bit lower heat so we can plenish it a little bit. So our welding should be done at this point. So pretty much from beginning to end, you're welding, because it takes a while for all that metal to touch each other on the inside. There you go. I'll let that cool down a little bit. We'll grind some off. So once those pins on the inside of all that airspace start touching one another, they have to be hot enough to actually start fusing together. So it's a welding exercise pretty much from beginning to end. You don't want to let it drop down too low below that. So we ground off one face on both sides. And you're over to the belt sander. Clean this up. And we went from 40 grit on this down to a 220 grit. We didn't go too fine with it. We just want to see what it looks like after an etch. See how we look. We are going to clean it up enough to see if there's any cracks or inclusions or anything. And it actually came out really clean. Nice solid piece. That's the back side with the scale still on it. And we do have one little tiny spot right on the edge towards the end. I gotta find it here. There it is. Little tiny spot. But it looks like it could be ground out easily. It's right on the back side. We'll drop this thing down into this etch. What we should end up with is one side that's got a nice dark edge from the high carbon steel. And then the rest of it, we'll have to see what it looks like. go. We left this thing in for about 20 minutes. And you can see a little bit of a pattern there. Have to get it in some neutralizer, spray it off, and we'll take a closer look at it. There you go. Well, there we go. A little different under this light. You're going to wipe that neutralizer and water off there real good. And I'll zoom in on it here with the camera a little bit so you can take a look. And you can still see some of the grinder marks. I didn't get too detailed with it. Looks pretty good. I like it. It's got some really interesting characteristic to it. You can see our edge there that we forge welded into place. Okay guys, a couple of points I want to stress. One is, if you're going to use alcohol in your shop, make sure that you're safe with it. Once it flames up, it's hard to put out. If it spills and flames up, you're going to have a mess. It's going to be a problem. So be careful if you do that. Be very careful. And be patient. Take your time. Don't overheat the chain and coax it along. It'll get there. If you go too quick, obviously it's going to break, it's going to fall apart, you're going to burn the metal, and you're going to have a big problem. Okay, this guy here, he's 16.5 inches long. He's 5/16 of an inch wide, or thick, and about 1 5/8 inches wide, a little over that. And we started with a 48-inch piece of motorcycle chain. This stuff right here. And once it's compressed down, that's what you get. And these are the bad links that we cut out. And the reason we do that is because you can see the roller is missing on this one, and that roller is bad, and the roller is missing on this one. And what you have to do is, once these things are all folded up and folded together, you can see the air space in there that you have to compress into. And that missing material on those rollers is going to give you less material to fill the area in with. It'll be uneven. You'll end up with voids. So that's why we inspect, and that's why we get rid of the bad links. This was a really fun project. I enjoy doing this kind of stuff. So if you got something that you want me to give a try and replicate or figure out how it needs to be done, go ahead and send it along. Which reminds me, I've been getting a lot of requests for tongs lately. And the problem is that a lot of those requests come through Facebook. Well, there's a problem with my Facebook. I'll get a message from someone, and then all my messages will disappear. And I'm sure there's folks out there that are frustrated. So if you need to get a hold of me, Facebook is not the way to do it. Send me an email at bigdogforging@gmail.com, and I'll get back to you. I've got tongs going out to folks who have contacted me that way. If you heard from me once and not again, and it's through Facebook, it's because it's flaky. I can't make it work, and it just doesn't seem to be reliable at all. So if you're looking for tongs, email. That's the only way to do it. So whether it's tongs or anything else you've got questions, or you want to send me something, or you need something from me, email is the way to go. And the last order of business is we're coming up on 5,000 subscribers, so we're going to do a 5K giveaway, and I haven't really decided what that's going to be yet. Maybe you guys can give me some ideas. Last time we gave away some tongs. I've got a bunch of Damascus. I could make something special. You guys let me know what you'd like to see given away for the 5K giveaway, and we'll do a little drawing. Alrighty? And take care. We'll see you next time right here at Big Dog Forge. Bye guys. We'll see you soon.